This is the first lecture on Chapter 1, Part 1. We're going to be looking at statistics, understanding what is the process of statistics, and then learning some terminology or some new language. Statistics is just a science, and it's a science of data. In that science, to analyze the data, we have some steps. First of all, we need a theory. And when we have a theory, we have some proposed or unverified statement. Notice it's unverified. Then we're going to go get some evidence. We're going to go collect data. So when you're doing statistics, you're basically an investigator. You're going to go get some data, and then you're going to look at that data and try to summarize it. And it might be that you need to go back and collect more data, or you need to go back and change your theory or your statement, a question of interest. And the last thing what we're going to do is we're going to interpret the results. And when we interpret the results, our hope is that we make a decision about our theory. Now, it's not going to be 100% correct. We could always make mistakes, and we'll talk about what those mistakes are called later. Some basic language or terminology that we need to know is the population is the entire group under study. And because we can't always look or identify the entire group, we're going to break that entire group into a sample, which is just part of the population. And we're going to use this part or sample to make decisions about the entire population. So when we take a sample, we want it to be a good representation of our population. So if our population were SKC students, and I wanted a sample, it might just be you, stat students enrolled at SKC. And that may not be a good representation of all students that attend SKC, but we need to make sure before we take a sample that it matches what our population dynamics are. If I'm looking at people in Ronan, maybe my whole population would be Lake County residents. And if I was looking at tribal colleges, maybe my sample is going to consist of SKC. Hypothesis. Hypothesis is a theory about the population. It's the question I'm asking. And again, it's regarding to the population. We have two. We have the null hypothesis, which means no effect or no difference. It's status quo. It's the prevailing viewpoint. It's no change. It's no change. It's status quo. There's no difference. It's the prevailing viewpoint. It's what's out there that most people are believing. The symbol that we use for the null is an H with a little circle here called, or red. When you read in the textbook, it's going to be read H, not. And mathematically, the symbols that this statement contains would be the equal sign, and that's most often. Sometimes it's written as less than or equal to. And we need to make sure that we understand that's less than or equal to. It's less than because when I read left to right, the pointy or the smaller end is on my left when I read left to right. And this then would be greater than or equal to. And what you need to realize, though, is it contains the equal sign. And we assume this to be true. It's assumed to be true. So what we need to do is gather enough evidence to suggest otherwise. The alternative, then, is the opposite of the null. It's basically my theory. It has symbols H1, and that's how you read it, H1. And mathematically, within this, it has the less than sign, the greater than, or the not equal to. So when I go and get my data to suggest otherwise, I'm looking to see where my data falls. For example, if I believe the average student in SKC is 33 years old, and that's what we all believe to be true, I go collect some data, and I find that students are really, on average, 22 years of age. I have gotten evidence that shows me otherwise. This would be my alternative. This is my null. So notice it's on this side of 33. It is less than 33, so we're also going to say it's on the left. If it's greater than 33, it would land on this side of 33, or the right. And if I'm not sure if it's on the left or right, but I just think, I was told it was 33. I'm going to gather evidence, and I see, I don't think it's 33, but I'm not sure, we would use the not equal to. As a researcher, might say, the average age is not 33. I'm not sure if it's left or right, so we're going to call that two-sided. So together, the null and the alternative make up all the possibilities. And you'll see that here when we do some examples. So here's an example. A medical researcher is interested in finding out whether a new medicine will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase or decrease? Notice, the researcher is unclear. It may increase or decrease. They just think it's going to change. The researcher, their theory, his or her theory, is the alternative. Notice, will be different. In other words, mathematically, they're saying the pulse rate will not be 82 beats per minute because of the medication. Now, we're believing that the medication does not or will not affect the pulse rate, so we believe it's status quo. We're believing that the patient will have a pulse rate of 82. The researcher, he has a theory, he or she has a theory that the pulse rate is going to change. Doesn't know if it's greater than, doesn't know if it's less than, just different than. So when they're testing this, they're looking for evidence that is not at 82, but greater than or less than. So they're looking at two sides of 82. I'm looking for pulse rates that are larger, pulse rates that are smaller. So in other words, we call this a two-sided test, because they're looking for evidence on either side of 82. Now the next lecture will give you the answers to the practice problems.